Hello students, now we are going to delve into the fascinating world of a nuclei. Nuclei are the heart of atomic structure and plays a crucial role in the behavior of matter. Let's begin by exploring what exactly nuclei are and why they are so important in our understanding of the physical world. So let's proceed with the topic introduction. So Rutherford discovery of an atomic nucleus caused scientists to ask how the nucleus composed. Every nucleus is composed of a particle that called as a proton and neutrons. Different elements have different numbers of proton and neutrons of the nuclei. Like in the case of a hydrogen, they have one proton and one neutron. But in the case of a helium, they have two proton and two neutron. Because of hydrogen have many isotopes, so in the deuterium, in the protium they have a zero neutron. So like this, as you can see, there will be a variations of protons in the numbers. The protons and neutrons is the most of the nuclei are bound together very tightly. So if we are just looking the structure of a nucleus, so these are the protons and neutrons, and they are bind very tightly. Because of that, we know that charge of the proton is a positive and neutron have a zero charge. That's why we are saying chargeless particle is a neutron. But they have some masses. Like the mass of a neutron is a 1.67 10 to the power minus 27 kg. And the mass of proton is a 1.674 10 to the power minus 27 kg. So there will be a minute difference between the mass of the proton and the mass of the neutron. Generally, nuclei can be treated as simple unbreakable particle in a chemical reaction or the atomic spectrum. In a nuclear reaction, a nuclear breaks apart or is assembled. These reactions can be released very large amount of energy. So how the nucleus is composed? Let's see in this topic of a composition of a nucleus. In Rutherford alpha ray experiment that leads to the discovery of a nucleus. When alpha particle bombard a gold foil, they are scattered in the different direction, which shows the entire positive charge, and the mass of the atom are concentrated at the center of the atom in the small volume, which is called as nucleus. So the nucleus is a completely positively charged, which is inside that atom, and the whole mass of the atom is concentrated at this particular point. For a more elaboration, I just want to take that one example. Like if you have one academic, where are you studying? So there will be some classrooms are there and there will be a field. So the complete field is called as an atom, and where if I'm just taking a nail, so that nail is a nucleus. That is small part is matter, that is small part of the matter is called as a nucleus, and that will be completely positively charged. So if people think that how much strong actually nucleus is and how much nucleus is small actually is. So nucleus consists of proton and neutrons together is called as a nucleons. A nucleus of an element X is represented by AXZ, where X represented the element, A mass number, that means the total number of proton plus total number of neutron, and Z is a proton number. So the total number of proton Z and neutron N inside the nucleus is called as a mass number, which we are saying as a A. So A is equals to Z plus N. And this is the Rutherford experiment, alpha particle scattering experiment. So in this particular experiment, what we are taking radioactive source of a helium nucleus. Helium is nothing but alpha particle. When the helium is actually get heat, alpha particles start to eject from this. And this alpha particle beam, because we have taken a particular field by which they get the direction. So because of this field, that alpha particle not moving here and there, they just move in a straight path. So this is a beam of alpha particle, which is a pass from the luminescent, that particular beam. So when the light rays, that when the alpha particle actually enters in the gold foil, most of the particle passes straight. But the thing is not actually that. Only few particles get reflected. In 1,000, only one particle. So that is the cause of like seriousness. Like why this one particle actually reflect? Because alpha particle have some positive charge, and we are saying alpha particle is a positively charged particle. So for the reflection or for the bouncing back, again a positive charge is needed. So who is playing actually the role of that positive charge? So by this experiment, like Thomson model will be created, by which we are saying that according to the plum pudding model, like a watermelon, there will be some seeds. So seeds are doing work as a negatively charged particle, and where whole the red particles, where the whole red system is called as a positively charged. So seeds are taken as a negative like an electron. We are saying this system or this model as a plum pudding model of a Thomson model. But the actual experiment which is done by the Rutherford is establish a new era in the field of atom. By this experiment, we actually known that in the inside of the atom, there will be a nucleus will be there. So atomic mass and composition of a nucleus. Nucleus is composed of a two things, which earlier I told you, proton and neutron. Proton. The mass of proton is a 1.673 10 to the power minus 27, which is a positively in nature, and charge is E, where E is 1.602 10 to the power minus 19 coulomb. If we are just taking the mass of the neutron, so mass of the neutron is 1.675 10 to the power minus 27 kg. Electrically, this is a neutral particle. The atomic mass of the atom is in the mass of the nucleus plus electrons. The atomic mass of the different element is different, and the periodic table contains an average value of atomic mass for each element based on the natural abundance of each element. The value of listed in the periodic table is the mass in the gram of 1 mole of atom. Now we are taking the properties of a proton, neutron and electron, because after knowing that what is actually proton, neutron and electron is doing, so that we can give actually the brief about the nucleus, and yes, of course, about the atom, like how the atom behaves. So proton charge is a plus mass of the atomic, like atomic mass unit is a 1.0073. Mass in a mega electron volt per speed of a light square, that is c square. So these are the important things which you have to prepare students for your board. At least you have to prepare these table. So mass in the kg you already prepared, charge you have already prepared. Only these three things we have to prepare. At least atomic mass unit you should prepare instead of a mass that mega electron volt per c square. Now, as we know from the Rutherford experiment, like in the atom there will be a positive charged particle which we are saying as a nucleus, and after the discovery we know that in the nucleus they have two things, proton and neutron. So the curiosity develops that okay, the size of a nucleus is can be, we can tell. The answer is yes. Size of the nucleus is approximately in the order of 10 to the power minus 15 meter. And the size of the nucleus was estimated in terms of the distance of a closest approach of an alpha particle in the Rutherford alpha ray scattering experiment. If the alpha particle of a kinetic energy approaches a target of atomic number z, if the distance of the closest approach is a d. So the value of E comes 1 by 4 pi epsilon naught to Z E square by D. I think students you heard about the Coulomb's law. I just taken this from the Coulomb's law. E is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So instead of a Q1 Q2, what we have actually? We have only alpha particle. And the mass of the charge of the alpha particle is 2 times the charge of proton. That's why we put 2Z E square by D. I hope you understand, students. There will be any confusion, if you can ask in the chat session. So move ahead. The radius of the nucleus of the mass number A is given by this, and R is equals to R naught a to the power 1 by 3, where R naught is equals to 1.14 10 to the power minus 15 meter is equals to 1.1 Fermi. The surface area of the nucleus is S is equals to A to the power 2 by 3. The volume V of the nucleus is directly proportional to the mass number, which is a V directly proportional to the R cube, or V directly proportional to the A. Nuclear density. Since nucleus is considered to be the spherical in shape, so volume V is equals to 4 by 3 pi R cube will be equals to 4 by 3 pi R cube by pi R cube times A. So the mass of the nucleus A into AMU. What is the AMU, students, over here? The mean of AMU is atomic mass unit. Which is 1.6605 10 to the power minus 27 kg. Density of the nucleus, the formula which we know, mass by volume. So mass in a particular mole, we have 1.66 10 to the power minus 27 particles. So if we have n number of molecules, so for that we just multiply it into n. But here we have atomic mass, means number of proton and number of neutrons here are A. So A into 1.66 10 to the power minus 27 by 4 by 3 pi R cube times A. After solving, we get the value of 2.67 10 to the power minus 7, 10 to the power plus 17 kg per meter cube. Density of the nucleus is independent of the mass number, and density of the nuclei is same for all the atoms. Density of the nucleus is of the order of 10 to the power 14 gram per centimeter cube, which is equals to 10 to the power 17 kg per meter cube. The density of a nucleus is maximum at the center and falls to the zero as we move radially outward. Nuclei do not have well definite boundaries, but yes, they have some range where the particle if want to enter, so they will feel a repulsion or attraction, depends on the nature of the particles. This is a diagram for the density and the distance covered by the center, by the particle at the center. This diagram will taken from the particular formula, which is the distance of a closest approach. Distance of closest approach. Atomic mass unit. The unit of atomic mass is called as an atomic mass unit. That means 1 atomic mass unit is equals to 1 by 12 into mass of 1 atom of a carbon, like C612. And 1 AMU is equals to 1.6605 10 to the power minus 27 kg. Now, mass of the some atomic particles, mass of the proton 1.0073 in AMU. Mass of the neutron 1.0086 AMU, and mass of the electron 0.005 AMU. As all these three values, I think you get a student. Electron is a very less mass in the nature. Their mass is a minute. 1 AMU is close to the mass of a hydrogen atom. Now let's move with the some question part so that you can understand like how much topic which you earlier learned that will be memorized to your mind or not. Like a nucleus consists of dash and dash. Together is called as a nucleons. Proton and electron, proton and neutron, neutron and electron, an electron and electron. The correct answer for this question is a B. Proton and neutron. Density of the nucleus is depends on the mass number, independent of the mass number, independent of the atomic mass number, and dependent on the atomic mass number. So here the correct answer for this question is independent of the mass number. Now moving ahead with the types of a nuclei. We have a different kind of a nuclei, like first is one is isotopes. Nuclei with the same atomic number but different mass number. Atomic number is a different thing and students, and mass number a different thing, are called as isotopes. Isotopes have same proton number. For example, 1H1, 1H2, 1H3. So the proton number is same, but as you can see that there will be a neutron will be changed the start. And the value of A is also changing regarding that. 3Li6, 3Li7. Isobars. Nuclei with the same number having different atomic numbers are called as isobars. Isobars are some number of the nucleons. For example, 18Ar40, 20 calcium times 40, like 20 Ca40. Isotones. Nuclei having the same number of neutron with different atomic numbers are called as isotones. For example, 17Cl37, 19K39. Isomers, atomic nuclei having same number, same mass number and some atomic numbers, but they have a nuclear properties which is called as isomers. For example, 35Br bromium 80 has two isomers with different life half. Now let's move with the question part. Atomic nuclei having same atomic number but different mass number is called isomers, isobars, isotones, isotopes. The correct answer for this question is isotopes. Atomic nuclei having same mass number but different atomic numbers are called isomers, isobars, isotones, or isotopes. So the correct answer for this question is second. Discovery of a neutron. Neutron was discovered by James Chadwick in 1932. When beryllium nuclei was bombarded with alpha particle 2He4, then nuclear radiation will start to emitted. 4B9 plus 2 helium He4 gives out the value C613 plus gamma. Then Chadwick predicted that the natural radiation consists a new type of a particle that called as a neutron, and the reaction is as follows: 4Be9 plus 2He4 gives out 6C13 and 6C12 plus 0 and 1 plus Q, which is energy. The natural radiation supposed to have more than available from the bombardment of the beryllium nuclei with alpha particles like this. Properties of a neutrons. Neutrons are diffracted by crystal. It is stable inside the nucleus and unstable outside the nucleus. Its half-life period is about 1000 kg and its life by the following process is 0 and 1 minus 1 and 0 plus minus 1 E0 plus theta bar. Its mass is nearly equal to that of proton. These composition of a nucleus can now be described using the following term symbol like Z atomic number or number of proton, Z neutron number, N neutron number, number of proton, and A minus mass number is equals to Z plus M. That means total number of proton and neutron. Now let's move with some questions. Neutrons are dash particle, so they will not be deflected by the electric and magnetic field. Options are negatively charged particle, positively charged particle, neutrally charged particle, none of these. The correct answer for this question is a neutrally charged. Next question, neutrons have low penetrating and low ionizing power, high penetrating and high ionization power, high penetrating low ionization power, and low penetrating high ionizing power. So the correct answer for this question is a neutron have a high penetrating low ionizing power. Students, this is it for today's class. I hope you like the session. If there is any kind of a doubt, you can ask in the chat session. Till that, take care.